Okay, so this video is going to talk about section 5.3, which is about linear functions. So we're going to start off with a little review. I want you to go ahead and pause the video and try this out, and then resume it, and we'll go over it together. Okay, so hopefully you tried these out on your own. Just as a reminder here, when we are taking our ordered pairs and putting them into a table, we're just making sure that remember the first number is x, the second number is y. Each point is getting its own column. Sorry, each point is getting its own row on the table. So 2, -4, -1, 0, -3, -3, and 0, 4. Just each point is its own row. When we go to the mapping diagram, we're going to put the x values all on the left side, like so. We're going to put them in order from smallest to biggest, and we're not going to repeat any of them. So this one, the x's don't repeat any of the numbers, so we don't have to worry about that. And on the y side, I'm going to put all of my numbers again in order from smallest to biggest. Then to show which pairs go together, to actually show the relationship between the x and the y, we're going to draw arrows. So from 1 in the x, I'm going to draw a line or an arrow to 2 in the y. So from 1 in the x to 2 in the y. From 2, I'm going to draw an arrow to -4. From -1, I'm going to draw an arrow to 0. From -3, I'm going to draw an arrow to -3. And from 0, I'm going to draw an arrow to 4. So x is our inputs, y's are our outputs. Then I'm going to go ahead and graph all of those points. So I'm going to just graph the points. 1, 2 is there. 2, -4 is there. -1, 0. -3, -3. 0, 4. And I've got my relation graphed. For the domain, since this is a discrete function, I just get to list them all off. Remember, domain is all the x values, range is all the y values, and I'll just list them. I like listing them from the mapping diagram because they're already in order, and we do like to list these in order from smallest to biggest. For the range, y values, same deal. And then when I'm talking about whether or not this is a function, I've got two choices of kind of ways that I would look at this. If I look at my graph, I might use that vertical line test and check to see that any vertical line doesn't go through 2 points. And so every vertical line I just drew only goes through 1 point. So yes, it is a function. We say that it passes the vertical line test. We could also look at whether or not any x values repeat. So in the table, we see no repeating x values. In the mapping diagram, there's no x value with 2 arrows coming from it. And those two things are the same exact thing, because if an x value repeated, it would be a point that's right above another point. And the vertical line test tells us that same information. So either way you want to think about this. That's not how you spell repeat. No repeat x's. Okay, now moving on to the new stuff today. Today we're talking about function rules or linear function rules. A function can always be expressed as an equation, not always, but a function can be expressed as an equation, or what we'll sometimes call a function rule. It is just a mathematical way to say, if I know the x value, what do I do to that x value to get the y value that goes along with it? Some examples of function rules might be something as simple as y equals x plus 2. Just saying I'm going to take whatever the x value is and add 2 to it. That's going to give me the y value. Or I could have multiplying. Y equals 2x. I take whatever the x value is and multiply by 2. Or I could be really complicated, right? Something we'll see eventually towards the end of the year might look like that. In which case, I have to start thinking about my order of operations. I'm going to square the number first, then multiply by 2, and then add 3. Any way we do this, the x value is going to get the x is going to get replaced with whatever x value we have. We're going to evaluate, we're going to figure out what that equals, and that's going to be our y value. We like to think of this like a machine in math, right? If a function is a machine, it takes something in, does something to it, and outputs something on the other side. So our input values are our x values, our output values are always our y values, and the points that they generate, x, y, is an input and an output. So if we take this function machine analogy here a little bit further, we can actually draw those out as machines. So if I have the machine that does y equals x plus 2, if I put a number like 5 into it, the 5 is my input, that's my x value. All I'm doing is just putting that 5 in for x. So y equals 5 plus 2, which we know is 7. That 7 is my output, or my y value. And so the point would then be the 5 comma 7, x comma y. If I do something a little more complicated, maybe I have something like y equals 2x minus 3. If I put in a number like 4, that's my x value, so I'm going to replace the x with that. I'm going to have y equals 2 times 4 minus 3. I need to worry about my order of operations, so 2 times 4 is 8, and 8 minus 3 is 5. So my output would be 5, and my coordinate would be 4 comma 5. Last couple of things here. I should do those one at a time. Sorry. Okay, talk through them. Another name we have for x values and y values are the independent variable and the dependent variable. The reason we call those x values independent is because you can choose whatever x value you want. Our function is going to let us put any number in for x, but we're going to pick the specific one we want to use at that point. The y value is called the dependent variable because it depends on what you put in for y. You put in a different number for x, you're going to get a different number for y. It also depends on the actual function rule. All of our points are going to be written in the form of x comma y, and the graph of the equation is just going to be the set of all the points connected to form a line or a curve. And the reason we're connecting our points is because we could really pick any values at all for x and y. We're just having to pick some convenient ones. Maybe we pick a number like 2 or 1. There's nothing that would really stop us from picking a number like 1.3. So if those are the points that I picked, I'm going to connect the dots. If my points look like this, well, I'm going to connect them. Usually from left to right is a pretty good way to connect those points. Next thing we'll talk about here is what a linear function is. So a linear function is going to be a function in the form of y equals x. Now that function could have something multiplied by it, so maybe like a 3x. It could have something added or subtracted to it, so like a plus 1. What it cannot have is it cannot have any exponents. It can't have any square roots. It can't have any dividing by x's. None of those things are allowed. Right? Just an x by itself, and then multiplied or divided by a number, added or subtracted by a number is okay. As far as a graph goes, you can kind of see here, the root word of linear is line. Its graph is going to be a straight line. So anything that looks like a straight line is going to be linear. So if I look on these, this x plus 5, that's definitely linear. It's just got an x with a plus 5. This one's got a squared, so it is not linear. This graph here is not a straight line, so it is not linear. This graph is a straight line. It is linear. Put a little L there for linear. And then what we're going to do for the rest of these problems is just take a linear function and evaluate it for different x values to help us graph it. So we'll start off pretty easy here. Our function is just y equals x. So we're going to pick some input values. A good rule is to just pick 2 negative numbers, a 0, and 2 positive numbers. And you want to pick numbers that are going to fit on the graph you're given. So if I plug in my x value into my equation where the x used to be, it says y equals negative 2. Well, that one's really easy because it's not actually doing anything to the x. It just says that the y value is equal to the x. So whatever x value I plug in, you'll notice the y value is equal to that. So I plug in my x value, y is equal to 1. Plug in my x value, y is equal to 2. I'm going to make ordered pairs out of these, which is just the x value comma the y value. And then I'm going to graph the points. And you will see when I do that, all of those points end up in a nice straight line. So I'll connect the dots to make a line, put arrows on the end to show that this line keeps going forever and ever. And then, is it a function? Yes, it is. It passes the vertical line test. What is the domain? So the domain here is going to be all real numbers. It keeps going forever and ever. It's a continuous function. The range is also all real numbers. If I move down here, we've got a little bit more complicated of a function, y equals x plus 1. So I'm still going to plot all of pick my x values, a couple positives, a couple negatives. And when I plug them in, now I have to do something to it. So -2 plus 1 is -1. -1 plus 1 is 0. 0 plus 1 is not 0, 1. 1 plus 1 is 2. And 2 plus 1 is 3. And so that'll give me all of my points. I'll go ahead and, should finish those, right? I'll go ahead and plot those points. -2, -1, -1, 0, 0, 1, 1, 2, and 2, 3. And when I plot those points, you'll see they are all in a straight line again. It is a function, passes the vertical line test, and since it goes forever to the left and to the right and up and down, I've got all reals again for both of those. So I'm going to let you go on this last one and try that on your own. If you want to check my answers on the packet, you certainly can, but I want you to try that one out on your own now.